In this last part, we will take a look at network protocols. We look at TCP/IP, that's the standard network protocols that are used in most networks. Then we look at higher layers um, and look at application layers. That's the higher layer that we will look at. So what is TCP/IP? TCP is Transmission Control Protocol and IP is Internet Protocol. It's not the only one, but it's the most commonly used one. This is what pretty much everybody uses because there's a lot of hardware and software built to support it. This is what's used in wired and wireless communication. Part of it works in hardware, and we say that the higher layers of the protocol run in software. So it's a mix of software and hardware. So this is sort of the layered structure of TCP/IP. You have the transport layer, and you have two protocols actually, even though it's TCP/IP. You have TCP and UDP. You can think of UDP as sort of like the movie mode or streaming mode, where you send out packets or segments and then you don't wait to make sure that it's received. Why? Because it's not crucial sometimes that you know that it's received. However, if you're sending a file, for example, you want to use TCP, the TCP protocol, TCP mode, I guess you could say, because every single bit in a file is important. If you have one bit off in a file, well, that could be pretty much make that file not usable. For example, if you have code and you have one bit off, that program just won't compile, right? So it's really important that every single bit be transmitted faithfully from source to destination. So this is the layer that makes sure that things are transmitted correctly. And a layer below that is the inner network layer. That's where we use things like IP addresses, either IPv4 or IPv6. Those are the two most commonly seen protocols at the inner network layer. And then below that is the network access layer, where we use Ethernet or fiber optic or WAN technologies, or sometimes, very rarely, token ring technologies. So this is the TCP/IP. These are the TCP/IP layers, and then above it are applications. So for example, if you have a web browser, you will be using the HTTP protocol to communicate with a server at a remote server, and then you send out a packet of information that gets sent down to the transport layer, which puts its information in what's called a segment. That gets sent down to the next layer down, which is the inner network layer, which adds on IP source and destination addresses and creates a packet that's sent down to the network access layer, where the Ethernet, the NIC and the Ethernet protocol generates a frame in which you put in the packet from the upper layer. That is the IP layer. Okay, so when you send something, you get data, you put that into segments, packets, and frames, send it out on the physical connection. Eventually, the receiving end gets that frame, unpacks the packet inside, sends the packet up to the inner network layer. The inner network layer opens up that packet, gets the segment, sends that up to this layer. This layer opens up the segment, gets the data inside it, sends it up to let's say the web server, which uses the HTTP or HTTPS. Okay, so that's the basic idea of the layered architecture, which we'll talk about quite a bit for the rest of the semester. And so protocols are the rules and procedures for communication and behavior. So computers must speak the same language and agree on the frame structure and the packet structure and the segment structure. That is, they have to agree on the rules of communication. And so when you have a protocol such as a set of protocols working vertically, it's called a protocol suite or a protocol stack, the most common of which is TCP/IP. I'm going to scroll back up. And the idea is that these things are interchangeable. You can have TCP work with let's say on one end you might have IPv4, or maybe you have, and that's connected to an Ethernet connection, or on the same machine you might have IPv6 connected to Wi-Fi connection. Okay, so these things are pretty much interchangeable. You can choose as the machine is running which protocol you want to use for which connection. And also HTTP can use TCP or UDP, so you can swap these out with HTTP. If you're streaming a movie, you can use UDP mode because it's faster. So you can switch between these different protocols from going from higher layers to lower layers. So TCP IP is composed of more than a dozen protocols and operating at different layers or levels of the communication process. So let's take an example. Let's say we have a browser and we want to access www.uwrf.edu, and what your browser will do is send what's called a GET request. It's a chunk of data at the application layer. So I'm going to scroll up. You're at this layer. Your browser is sitting above the application layer, and it sends something out here to the HTTP layer and says, I want to get this website information for this website. The data that you create has essentially like a GET request, and then the URL or the address, and then the HTTP layer or protocol passes this data to the next layer down, which is transport layer or TCP layer, which takes that data and adds a header which actually has information about ports and IP addresses and things like that, and so it joins these two things together, and then that forms a segment. The transport layer then passes this down to the next layer down, which is the internet protocol layer or IP layer, which takes that data, the TCP segment, adds its own header with IP addresses to form what's called a packet, and then the IP layer takes that whole packet, sends it down to the network layer, which is the layer of the network interface card in the hardware, and that layer adds a frame header, right? So the frame header and a frame trailer, which has the frame check sequence, and that thing is what's in a frame. So when at the receiving end, so this goes out of a NIC and is sent out in the network medium, whatever that is. It can be Wi-Fi, it can be fiber optic, it can be Ethernet on copper wire, and then whatever receives it checks the frame destination MAC address. If this is in the right place, then you open it up, take out all of this. Of course, you do check and make sure the frame check sequence matches the CRC code that you compute, and if they are equal, then you look inside and you find the packet, and then you look at the destination IP address. If it's in the right spot, you open up the segment and then you send that up, and then the web server gets that GET request that's in the data. Okay, so application layer protocols basically provide the high-level network services to applications like browsers or network or web servers, things like that. And so with most application layer protocols, you have both the client version and a server version. So a server version would be, for example, a web server application, and at the client end would be like a web browser application. So application layer protocols usually allow access by applications to network services. So a browser has access to the outside world. You can, as long as you have a URL, you can access pretty much anything you want. You have things like name resolution happening at the application layer. So if you send out a request to www.uwrf.edu, there's something software at the application layer that figures out where that is it has to figure out the IP address. It can do dynamic address assignments and handles authentication and login. So if you have to log into www.uwrf.edu/something, then all of that is handled in that layer of software or protocol. Okay, so HTTP is the protocol of the World Wide Web, and originally its main purpose was just to transfer static websites. And so these days it's gotten a lot wider. It's used for general data transfer, for downloading, displaying multimedia files, all of that. And it's also used for web applications, things like that. HTTP uses TCP as its transport layer protocol, and the default port number is 80. So if you're sending out an HTTP GET request, that goes to the server. It's received at port 80 at the server end. So when you say get HTTP, whatever version of HTTP that you use, and then let's say www.uwrf.edu, you do have to find out what the IP address is of the uwrf.edu part, but then at the server end you get that at port 80 usually. If you use HTTPS, you might use a different port number like 443 or 8443, something like that. Those are all port numbers that basically decide which application will get that request. There are other protocols that are used. For example, email uses POP3 or IMAP or SMTP. These days, I believe they all use SMTP, or you might use just email over HTTP. POP3 is old. It uses port 110, TCP port 110. IMAP uses port 143, and SMTP uses port 25. Okay, so if you use a mail client like Outlook, for example, that will most likely use SMTP, and so you'll use port 25. But if you're using a browser to read your email, then you're really just using HTTP. There are protocols to transfer files. So FTP is a good one that a lot of people use, or you might use the trivial file transfer protocol, TFTP. It is less secure and it's a simpler protocol. FTP has the classic client-server protocol. It uses port 20 and 21. 20 is used for users sending control commands, and then port 21 for transferring file data. Usually FTP you use a high numbered port. A high numbered port is something above 1,000, so something like 50,520 or something like that. So that's what's used to transfer files usually. So you use the ports 20 or 21 to set up the connection, and after that you use a high numbered port. TFTP has much less file management capability and uses UDP. It's meant for really fast file transfer using port 69. SMB is a protocol that Windows uses to share files usually, or resources in general, and it's used in private networks, not on the internet. SMB uses port 455. Although it's usually set up or done with Windows, most other operating systems like Linux and Mac OS X also support SMB, and so they are slightly different, but they use the same port number. And lastly, this is a protocol that we will use in the lab called Remote Desktop Protocol. This uses ports 3389, port 3389, either TCP or UDP ports 3389. What it allows you to do is, once you set up this protocol, you can view a remote machine using a graphical user interface. So it's an application that allows you to access the desktops essentially of other computers, a remote computer, usually a server, but it can be any computer pretty much. And so main reason for using this protocol is to be able to access Windows or graphical user interfaces that are running on a remote machine. And we will use it in this sense of administrators using RDP to manage Windows from when they're not sitting in front of those workstations or servers. So we'll use it in the lab. We'll use it to manage our server in the lab downstairs. All right.